Hello and welcome to our final vlog in our series of finding a replacing player using Alteryx and Tableau. In the previous vlogs we've been using Alteryx's predictive grouping tools. Today we're going to look at Tableau's visual analytics capabilities to find our replacement players. First, I'm going to delve into the Alteryx workflow we created in the first 3 parts of this vlog series and have a little recap. We have our 2 files which are created from a season's worth of up to F24 files. That's from the 2010-11 Premier League season. We have our matches database, which has basic match info such as time played and position by player by match, and our events database, which is an event by event database for every single match in the season that contains all the performance data we're going to need for this workflow. We join these 2 databases together to get the performance data and the position name for each player for each match, and then we filter to just centre or defensive midfielders. We then summarise the performance data to be the sum across all the season for our 4 metrics we feel are key to Stuart Holden's influence on the Bolton Wanderers team. That's ball recoveries in the middle third, interceptions and key passes. We add in the time played from our matches database and filter to players who have completed more than 90,000 seconds of player time, that's around 15 matches, and we then standardise our 4 metrics to be per minute. Next we have our principal component analysis tool and our cluster analysis tool, and we can check out the data output we get from these. So, here we have by player their performance metrics and principal component 1 and 2 plots, as well as their cluster group. So if we take a look at Stuart Holden, we can see that he belongs to cluster group 1, and we can also see his principal component 1 and 2 plots, which we will be exploring later in this vlog. If we go back to our workflow, we also have our Find Nearest Neighbour tool, in which we have a filter to Stuart Holden, and the true output of this tool becomes our query input, and our false output, so all the other centre midfielders, become our data input for the Find Nearest tool. If we then take a look at the output from this tool, we see we have Stuart Holden and our 5 most similar players to Stuart Holden in terms of their Euclidean distance. I'm now just going to remove these browse tools and add an output data tool, first to our combined principal component and cluster data stream, and call this PCA cluster.tde. Then, before anything else, I want to make a couple of tweaks to our Find Nearest Neighbour output to make the data in a more standardised format to work with in Tableau. So I'm just going to open up a new workflow to show you what I have done. You can see here we have the same workflow but with this little addition at the end. If we just take a little look at the original output, we have sort of a mini crosstab, whereas actually what we need is just a small table with 2 columns, one for player name and one for that player's Euclidean distance from Stuart Holden. So to do this, I have just used 6 select tools, in which each tool I have selected the relevant player name and distance field for each player, and renamed those fields to be player name and distance. So each of our outputs will look like this. The only exception is the Stuart Holden output, in which we had no distance data. So I've just added in a formula tool that makes Stuart's Euclidean distance from himself to be 0. I have then just unioned all these streams of data back together, so our output looks like this. I'm then going to add an output data tool to this stream of data and call this nearest.tde, and then run the workflow. You will then see in our results messages section here, we could open up our Tableau data extracts directly from here, and this will open up Tableau for us. But I'm going to jump into Tableau and open it from within there. So here we are in Tableau's start page. Now, one thing I'm going to state here is you might get a lot of ums and ahs in this, because unlike the previous vlogs in part 1, 2 and 3, we're actually going to do this all completely off the cuff. No structure to it or anything, because that is the power of Tableau after all. The idea is that we can start to explore our data and visually analyse in a very sleek and very quick manner. So I'm going to start by connecting to our data. So our files are saved to our desktop, and I'm going to first start by connecting to the nearest.tde file that we created. We can see here the information we have regarding the player names and their Euclidean distance to Stuart Holden. Now, how do we start visualizing this data? Well, quite simply, we could just, double click our player name, double click the distance, and here we've got each player's Euclidean distance. Now, first thing I'm going to notice is Stuart Holden's at the bottom of this list. So what I'm actually going to do is I'm going to sort the player names based upon their Euclidean distance. I'm just going to manually do this for now. So that's Stuart Holden, and also I think it looks like Scott Parker and then Emilias are the wrong way around. So there we have it. Very simple, just a table. Nice little crosstab. So what about if we were to start to perhaps colour this table based upon their Euclidean distance? We could colour the text, so we see the darker the text, the further away they are from Stuart Holden in terms of statistical similarity. Perhaps we might want to just explore this in a different way, so turn it into perhaps a heat map. So if we change this to a square rather than automatic, we get a nice little heat map there instead. Now, instead of doing this, we may want to turn this into a bar chart. We might think that this doesn't quite show the differences enough. We're looking at numbers there. How can we tell, the difference between Ben Watson to Stuart Holden and Danny Murphy to Stuart Holden, or Luka Modric to Stuart Holden? Well, let's just turn this into a bar chart. So, just by dragging distance up to there and selecting bar, we now have a bar chart. So we can see actually that Ben Watson and Danny Murphy aren't that too dissimilar in terms of their likeness to Stuart Holden. Similarly with Luka Modric and Scott Parker, the same thing. And then Emily has a bit further out there at 1.334 in terms of Euclidean distance. We could perhaps turn this into a lollipop chart. We may want to just dual our axes there, so if we drag another distance one on, and we've got two charts, but what I'm going to do is on this one here, I'm just going to right click and go dual axes. And here we have two bar charts on top of each other. What I'm going to do is the second axis, I'm actually going to turn into a circle mark. And then the bar chart, I'm going to shrink the size right down to its minimum. I'm just going to make sure that the axes are synchronized. And what I may want to do is just perhaps fill the entire view of this page, bring out the size difference, we might want to just put the Euclidean distance perhaps as a label, and we'll pop it, in this case we're going to do it within the circle. So we just do that. There we have, so just a different way to visualize our data. We may want to also remove this top axis, and we could even remove the bottom one because we've actually got the Euclidean distance here within our circle marks. So it's just another way of visualizing the data. Now another thing we could do actually is if we remove one of these, instead we've got our circle marks, and perhaps just remove the players from this row so we don't get every circle broken down by the player. In fact, we're going to drop this onto our detail. So instead of having a different row for each player, they're all on one row and they're all marked out here. Now instead of showing their distance, I'm going to remove that. And actually I'm going to use player name as the label. Now what I'm going to do is I'm actually going to then just change the orientation of the label. And move it around a bit so we can show all the marks, and also allow labels to overlap other marks as well. So there we can see all of our players, from Stuart Holden right the way through to Ben Watson, next nearest in terms of similarity, to Danny Murphy, Luka Modric, Scott Parker, and then Emily Haas. Now, just to add another visual look at this, I'm just going to again dual the axes, similar to before. And this time, the second axis, I'm actually going to change into a line. I'm going to remove the player name from the labels. I'm going to ensure that the axes are synchronized by right-clicking and going Synchronize Axes. And then I'm just going to also make sure that neither of the headers are showing. And here we have another way to visualize that data along the line with marks. Now, the importance with this really is not to just make sure you create vizzes for the sake of creating vizzes, but it's actually to think about your end user. What's going to represent the data best to them? What's going to tell your story best to the end user? Here, I think the line that we've created adds just a little bit of extra context, just to show that we are talking about connection between these players. We're talking about the connection between Watson to Holden, Murphy to Holden, Modric to Holden, etc. Already we can see how Tableau can be used quick and simply, but in effective ways which we can explore our data. So next, let's have a little look at our cluster analysis and our principal component analysis data set that we created. So I'm just going to go up to Data and New Data Source. So I'm just going to connect to our PCA cluster.tde that we created in Alteryx and open that up. You'll see we've got our player ID and player name, and then all the metrics, as well as our PC1 and 2 plots and our cluster group. I'm just going to go to and create a new sheet now. And then the first thing I'm going to do is start to explore the clusters that each player is in. So we could do that by potentially just bringing out player name to rows and perhaps dropping cluster on. Now, one thing to note is cluster is down as a measure here because it's in numbers 1, 2, 3, 4, and 5. But in fact, they're not measures, they're dimensions. It's what we want to break our data up by. We don't want to do sort of sums or averages of these clusters. We want to just break up our data based upon this cluster group. So I'm going to drop it into a dimension. Then I'm going to drop this cluster on to colour. And you'll see here each player and each cluster group is represented by a different colour. So we have, for instance, cluster 2 are all the oranges, cluster 3 are all the greens. So we've separated this out now. But let's have another look at this, perhaps what else we could do to make this a bit clear, because at the moment we've just got a table of player names and a colour that represents a cluster, which isn't very insightful at all. So perhaps we could drag our cluster out onto player name and actually group by our clusters. So we've got all cluster 1, 2, 3, 4, and 5. So perhaps it clears things up a little bit, but again, the colours, the marks aren't really telling us a lot in this case. So why don't we start to look at the metrics that we've been considering throughout this vlog series. So we've got ball recoveries, we'll select these four. What we're going to actually do, they're the four we're going to look at. We're actually going to use this measure values. We're going to drop this onto columns. Now here, we've got various measure values which range from ball recoveries per minute, interceptions per minute, key passes per minute, and match seconds played, and number of records. Now, a number of records is something that's created through Tableau directly. It just puts a 1 next to every row, so you can count the number of rows you've got in your data set. Now, what I actually want to do is, first of all, I want to remove some of these fields. So I'm just going to drop the measure names onto filters, and I'm just going to select the ones I want, which are all the metrics that we've been looking at, the 4 metrics. Click OK. So what I also want to do is, at the moment we've just got all of our measure values, all of these metrics, segmented out here in almost a stacked chart. Now what I actually want to do is split those out a little bit. So I'm actually going to drop measure names onto here. I'm going to drop it the other side of player name actually. So we've got our cluster group, we've got our players, and we've got each of their metrics. can see if I go down to the next cluster group, we'll have all of their metrics. Now, the colours aren't telling us a lot, and let's go back to our first initial question, and that was, who can replace Stuart Holden? So I think we should narrow it down straight away to cluster group 1. So I'm just going to add that to my filters. I'm just going to say I'm only interested in those in cluster group 1. So there we have it, just cluster group 1, but now the colour's really not telling us anything at all. So I'm actually going to use measure names as my colour mark, so by dropping it onto colour, here instead we've actually got all of our players, the 4 metrics, and these metrics are coloured to distinguish which one's which. Now what we could do with this is start to explore Stuart Holden compared to the other players. So for instance, I'm actually going to just flip the axes on this. It's not ideal because the player names are now in the opposite, or the metrics are in the opposite direction, even though the player names aren't. However, what it does allow us to do is see every player in one view. And this end column, where Stuart Holden is a key one for us. Now perhaps we want to look at how Stuart compares in each of these metrics to everyone else in cluster group 1. So I can just select ball recoveries in the middle third per minute and start to see where Stuart Holden fits compared to the others. So we're just looking at the data visually here and just starting to get an idea of which players are most similar and how they vary. So for instance, if we were to look at Scott Parker here on ball recoveries per minute, significantly stands out compared to the rest of the players. So if this is something that we had a lot of weighting on, or the coaches and our management team had a lot of weighting on, then perhaps Stuart Parker would be a standout figure in this case. Likewise, if for instance key passes per minute was a vital one and we were to select key passes, we'd perhaps look down here and look at Milias and say, right, his key passes is lower than everyone else. Is he someone that we rule out straight away or not? So again, it's just a nice way of visually exploring our data and our options. So let's move on from this and actually start to use our principal component plots. I'm going to just add a new sheet here. And first thing I'm going to do is drop on principal component 1 and 2 just by double clicking. And what we have here is just one plot, which is our sum of our principal components 1 and 2. What we actually need to do is just split this out by player by dropping it onto detail. We can see now we've got all of our players on and their principal component 1 and 2 plots. I'm just going to reverse this axis just purely because I think from a visual perception point of view, it's a lot easier for the human to understand the spread going from bottom to top as opposed to top from bottom. Now, so we have all our players. I'm going to turn these into circle marks. And if I hover over, for instance, I'll be able to see this is Hendry Thomas here, and that's his principal component plot. Morten Gamps Pedersen there, and we can go through every single player. Now, straight away we've kind of got a group of players down here, so these are fairly similar. But what we may want to do is actually split this out by the clusters and actually distinguish each individual cluster. So I'm just going to drop cluster onto colour, increase the size a little bit, and already we're starting to see we've got our groups of players. We've got this top section here, this top left, a middle section, a lower middle section, and our bottom section here, which are all our cluster groups of similar players. So those that are within this green group are considered similar based upon the metrics we've looked at, and similar with the blue group and the red group, etc. If we start to look around this information, we'll see the various players who we've got. Michael Carrick there, for instance, and then Milias there, who's one that's come up on our Euclidean distance as well. And if we just go to this mark here we have Stuart Holden. Now, this is what we're after. We're after players who are similar to Stuart Holden in the 4 metrics that we've been looking at. So we can start to look across this cluster group and start to look at the players. We see similar players that we've come across before: Scott Parker, Danny Murphy, there's Ben Watson again. Over here we've got Charlie Adam, we've got Stephen Gerrard. It's a nice visual way of exploring our data and saying, right, okay, so which players are in the same cluster group as Stuart? Well, we've got Stephen Gerrard, but realistic chances of signing him, of him wanting to go to a club like Bolton, it's not going to happen. We've got Mark Noble. Again, that might be a hard persuasion point, and wages might have an impact on whether Bolton could have signed him at that time. So perhaps not a possibility. Go across to someone like Milias at Wolves. Perhaps that was a possibility. Again, let's look around this other cluster group. Graham Dorrans, potential opportunity there as well. So there's a few around in that group that may start to focus your attention a bit more as to your recruitment strategy. We may also start to look across, okay, who are close in terms of the distance, the principal component 1 and 2 plots. So again, Ben Watson was a standout there, and we had Danny Murphy and Scott Parker. But also, not too far away over here, although in a different cluster group, we've got Alex Song and John Obi Mikel. Now, they may be unrealistic signings, but it may just start you to think, perhaps that is the sort of player. They're not too dissimilar to Stuart Holden, but they offer potentially different options to Stuart. So, which players are similar to those two players who are in the red cluster group? So let's have a little look around, and we can see over here you've got Yusuf Malumbo. Now, there's a good opportunity. Potential to sign him, not unrealistic. So we've started to identify a player that perhaps we want to consider a bit further, and perhaps we may want to look a little bit more, perhaps worth investing a bit more time in analysing and scouting him. This means visually analysing our data can be both a powerful and efficient way of identifying potential new recruits, but also a very clear and simple way for your football staff to explore data without having that fear factor of looking at a load of numbers they don't really understand. So I'm just going to jump across the dashboard that I've created using these concepts we have been discussing to help us answer our initial question of who could Bolton Wanderers have bought to replace Stuart Holden in summer 2011. From our data, I think we've already identified that there's one clear standout candidate. Here we have Ben Watson, Euclidean distance from Stuart Holden there. Closest match, we've got him in the same cluster group and also close in terms of his principal component plot. This is a man who in the 2010-11 season was a key part of helping Wigan retain their Premier League status. In 2013 scored the winning goal in the FA Cup final. He helped Watford gain promotion to the Premier League in 2015 and is currently playing a key role for them within the Premier League. So is this my answer to who Bolton should have signed in the summer of 2011 to replace Stuart Holden? Maybe. Now, the reason why I say maybe is there's lots of other things around that, player wages, signing fees, etc. You'd be looking at medical and sort of injury history. On top of that, I wouldn't really want to narrow it down to just this one player. I'd want to look at all the players that are around here. So I'd like to consider the likes of Danny Murphy, Nene Milias, perhaps delve into the other areas, looking at Yusuf Malumbu, Stephen Gerrard unrealistic, but perhaps someone like Graham Dorrans as well. So different opportunities have arisen from our analysis, both in terms of statistical analysis and the visual exploration of the data. But I think it certainly narrows down our pool of the players that we could be looking at to replace Stuart Holden. Now, as an added little touch to this, perhaps when we want to explore our data, we add a bit of interaction to it. So by, for instance, me selecting Graham Dorrans, I can start to compare the metrics that we've been looking at. For instance, the regains middle third, interceptions. I've thrown shot assists in there as well, just to look as an additional metric, and key passes. So we can start to compare both the rank of each individual player and how they compare to Stuart Holden. Again, if we go over to Ben Watson, we'll see a very similar pattern, and perhaps he ranks even higher on most of the metrics, in fact. So we're really getting extra detailed information that's relevant and specific to our original goal. Now, I've placed this dashboard on Tableau Public, and it's available for download for you to explore how it's been built, as well as just to explore the data yourselves. Thank you for joining me for this Ultrix and Tableau in Sports series. Doing these 4 vlogs has been a great pleasure. Hope you enjoyed them, and I hope you learned something from them. See you again soon.